Good evening. This is all about light, but somebody asked me if I can do 360s in my cowboy boots. And I really don't know. Ah! No, it feels horrible. Ah! God, it does feel horrible. Ah! Fail. Right, last go. Far out. No is the answer. Yes, but only just. Light. Headed. Does light travel forever? Astronomy made simple. 2 minutes and 38 seconds. Light doesn't travel forever, okay? Light is absolute. Go.
Does light travel forever? Have you ever wondered if light can travel endlessly through space?
No.
This question takes us into the fascinating world of astronomy and the nature of light itself. Light is made up of tiny particles called photons. These photons can travel incredible distances without losing energy.
So, what happened to the closest star to us other than the sun? Where is its light? Where is Barnard's star's light? Where is Wolf 359's light? Where is this light? Why, during a solar eclipse, is the sun directly behind the moon? How is it possible that somebody standing on planet Earth is in the moon's shadow and the sun is directly behind the moon? How is that possible if it takes 8 minutes and 20 seconds for light, for Mickey Mouse photons, to hit the moon from the sun? The moon then casts its shadow onto us. It cannot be. It's so obvious. It's like the Egyptians and the pyramids. Pyramid Giza weighs the equivalent of 100,000 Abraham's main battle tanks, okay? It's a fact. 100,000 of them, 25,000 Egyptians, that's 4 tanks each. There's 2.3 million 2.5-ton stones, 25,000 Egyptians. 2.3 million stones, 2.5-ton stones, and other stuff, right? 25,000 Egyptians. 2.3 million stones, 2.5 tons, 25,000 Egyptians. 2.3 million, 25,000. 2.3 million, 2.5-ton stones, 25,000 Egyptians. The absurdities are staring people in the face. This is the worry.
Unlike sound waves that fade away as they move through the air, light can move through the vacuum of space, which means it does not need a medium like air or water to travel. This unique property allows light from stars billions of light years away to reach us here on Earth.
What? What did she say? This allows stars that are billions of light years away to reach us here on Earth. No. The closest star to us, other than the sun, cannot get its light to us because it is not powerful enough. What is she talking about?
Which means it does not need a medium like air or water to travel. This unique property allows light from stars billions of light years away to reach us here on Earth.
What? The furthest? Look, every time I say light year, I'm saying it because that's what they say. There is no such thing as a light year. There is no such thing as a light year. the furthest we can see, they reckon V762, it's a star in the constellation Cassiopeia, and they say it's 16,308 light years away. Rubbish. Whether it's light years or not, there's a certain amount of kilometers, what is it, 10 trillion or something for a light year. If you are seeing a light source anywhere, a star in the night sky, you're seeing it because it is powerful enough for you to see. That is why you're seeing it. That is why you're seeing it, because it's powerful enough. If it wasn't powerful enough, it would be on, but it would be much like Proxima Centauri, which is the closest star to us other than the sun, and we cannot see it. How is that possible? Is she talking about light that has reached us from billions of light years away because of the telescopes? That is still absolute light, and it does not matter what you're looking at a light source with. If you are seeing a light source, whether with the naked eye or with a telescope, you're seeing absolute light. You're seeing things exactly where they are. There is no delay. There is no delay. Where is Proxima's light? Why is the sun directly behind the moon during a solar eclipse? The reason that the sun is directly behind the moon during a solar eclipse is because there is no delay. It's absolute light.
When we see this light, we are actually looking back in time, witnessing events that happened billions of years ago. Photons are interesting because they have what we call an effectively infinite lifetime. This means they do not simply vanish or change into other.
There can be no light without a source. If the source goes out, the light goes with it. There can be no light without a source. It's so obvious, right? I'm starting to get that freaking it really hurts thing going on. Oh, how many times? And the thing is, it's not like I'm saying something and all around us there's evidence that contradicts what I'm saying, right? Don't start up with your GPS and your LiDAR and that rubbish, because that's got nothing to do with anything. A solar eclipse, they've been happening for a lot longer than GPS has been around, right? There is no delay in any light source. There is no delay in the light reaching us from any light source. If the light source goes out, the light disappears as well. There can be no light without a light source.
For particles under normal conditions. Once a photon is emitted, it can continue its journey through space indefinitely.
Unless your name is Proxima Centauri and you're the second closest star to Earth, then I'm afraid your photons cannot travel indefinitely. If you're called Barnard star, same deal. And Wolf 359, you will not see a single photon from any of these stars. Why not, sir? Because they are not powerful enough to radiate their light here. Or it could just be a coincidence. And the three closest stars to us, other than the sun, are all duds. And they just have a little bit of trouble with the photon machine. But all of the other ones, I haven't got much stick left. I don't want to hear.
However, there are exceptions. If a photon interacts with matter, such as dust or gas, it can be absorbed or scattered. This does not mean the photon.
And if a photon accidentally interacts with common sense, it disappears altogether. Not the common sense, the photon. Photons and common sense cannot coexist in the same universe, right? A solar eclipse, the way they play out in our universe, that simply cannot coexist in a universe with finite light, with delays and stuff, right? So, as you can see, the photon, it's amazing that it's still going. It really is. But they do travel forever, don't they?
Disappears. Rather, its energy or direction changes. In astronomy, we measure the distance light travels in light years. 1 light year is about 5.88 trillion miles or 9.46 trillion kilometers. This unit helps astronomers grasp the vastness of the universe and the time it takes for light to travel from distant objects to us. Since light travels at a constant speed of approximately 186,000 miles per second, or 300,000 kilometers per second, observing distant stars and galaxies allows us to see them as they were when the light first left them.
Here it is again. When the light first left them. A light source, right? If you can see a light source in the night sky, talking about stars, right? The reason you are seeing that light source is because it is powerful enough to radiate its light and your eyes can detect it, right? If it is not powerful enough, the light won't reach you the day after tomorrow. That should be fairly obvious, right? The reason that you're seeing all the stars in the night sky that you see, you're seeing them because they are powerful enough to radiate their light that you can detect it with your eyesight. That is the reason that you're seeing them. You're not seeing them because light is just traveling indefinitely and just keeps on trucking. No, that does not work like that. No, sir. Light is absolute. No source, no light.
So does light travel forever? In essence, yes, light can travel indefinitely through space unless it encounters some...
Unless its name is Proxima Centauri, Barnard Star, or the Wolf 359. Everything else just travels forever. Just these three, the ones that are closest to us. The ones that would give the game away, in fact.
Something that absorbs or alters it. This remarkable ability makes light an essential tool for astronomers, enabling us to study the universe across immense distances and timescales. The next time you gaze at the night sky, remember that the light you see is a glimpse into the past.
The next time you gaze up into the night sky, rest assured that every single star you see in that night sky, you are seeing it exactly where it is. Slam dunk. There is no evidence to say otherwise. In fact, all of the evidence is, it actually proves that light is infinite, absolute, not infinite. We have the solar eclipse where the sun is directly behind the moon. There is zero delay, no delay whatsoever. If light were finite, as photons left the sun, the shadow that we see, they say, coming from the moon, that shadow, the photons that are hitting the moon had been traveling for 8 minutes and 20 seconds. They'd left the sun 8 minutes and 20 seconds earlier. So as soon as those photons started their trip, right, of 8 minutes and 20 seconds, Earth was slowly turned on its axis by 2.08 degrees. That means by the time the photons arrived here, Earth would have spun out of the way of the sweet spot. The sweet spot would never, ever be possible. It would never be possible because the shadow that is being cast onto Earth, the photons that are casting that shadow have been traveling for 8 minutes and 20 seconds. And that means when the photons that are hitting the moon in that perfect sweet spot moment, those photons that have been traveling for 8 minutes and 20 seconds, in that 8 minutes and 20 seconds, planet Earth would have turned anti-clockwise on its axis by 2.08 degrees. How is it possible that the sun is still directly behind the moon? And that shadow, that perfect sweet spot moment, depending on Earth's axis spin and the little bit of movement from the moon, that sweet spot will go from west to east, from southwest to northeast. In the case of the US, in April last year, I think it was, you have that. And then we have this finite light, the Proxima Centauri, and it is the closest star to us, other than the sun, apart from the sun. But this light that just keeps traveling forever does not seem to be traveling forever from Proxima. Very disappointing, Proxima. But Barnard's as well. Wolf 359. Detention, all three, for messing around.
Traveling across the cosmos and continuing its journey through the universe.
Subscribe for what? Don't tell me. $5 a month or $5 a year? I don't think so. Cha-ching! Cha-ching! Guys, nobody has ever seen any finite light anywhere. Nobody has ever seen any delay. Ever. Right? There is only one occasion, and everybody is in the same boat to see light in action, light from the sun. And that is during a solar eclipse, right? During a solar eclipse, if light were finite, the sun cannot be directly behind the moon. It cannot be directly behind the moon because Mickey Mouse photons apparently take 8 minutes and 20 seconds to come from the sun towards the moon. In that 8 minutes and 20 seconds, planet Earth is turning anti-clockwise on its axis and will turn 2.08 degrees. Therefore, when those photons finally hit the moon and the shadow is cast, why is it that it's still lined up perfectly as if we haven't moved? Do you know why? Because the light radiating from the sun is absolute. There is no delay. There can be no light without a source. As soon as the light source goes out, the light disappears at the very same time. Sun, if it turned off, we'd be plunged into darkness and cold within a heartbeat. Again, the evidence, the closest star to us, other than the sun, and we cannot see it with the naked eye. Barnard star, cannot see it with the naked eye. Wolf 359, oh! We cannot see any of their light. So what is this thing about light just keeps on going forever? It's rubbish. Light will radiate only to a certain distance, and that distance, it's radiated at absolute speed. Boom! If you cannot see a light source after it switches on, in a second after it switches on, like absolute speed, if you cannot see it, light is not going to make its way to you over a period of time because it's traveling. It doesn't. You either see a light source from the onset or you don't see it at all. It's obvious, and all of the evidence, it's right there in front of people, but no. Just like the Egyptians quarrying the equivalent weight of 63 battle-ready Nimitz-class aircraft carriers with copper hand tools in their bare hands, you believe the Mickey Mouse-ness, right? What is there to say? I will be back with more. I had another good one to listen to. Well, obviously they're all live. Once you've heard, it's like a magpie. Once you've seen one, you've seen all of them. Well, that's not really true because they are different personalities. Look, you know what I mean. These programs, it's unbelievable. It's unbelievable. All right, I will be back. A weekend packed full of absurdities to get through. Latest peeps. Oh, hang on, look. Let's just, is there any clouds? The Proxima, look, I'm gonna get a telescope. It's been ages since I got a telescope out. See these stars? Actually, that is, oh God, it's that one there. It's Proxima. Sure it is, it's the bottom one. Pretty sure it is, you know, it's not those ones up there. See, this is what happens when you don't check in on the night sky. Those stars, look, we're seeing them because they're powerful enough to radiate their light so our eyesight can detect them. That is why we are seeing them. Now there's a star somewhere, right? I'm sure it's this. Look, I'm going to get a telescope out after. If those two there, so binary star system, right? I'm sure that is the Proxima Centauri A and B. Proxima Centauri is actually there, right? In front of those two, or slightly to the left or slightly to the right, but we cannot see it, right? It's there, that's where it's at, but we cannot see it with the naked eye. Now, how is it possible that a star that is the closest one to us, apart from the sun, how is it possible that we can't see it? How is it possible that we cannot see that star? It isn't possible if light travelled forever, or if it were finite. We'd see it, but we cannot because it is not powerful enough. Whereas all of these are powerful enough. It's really that basic. Cool stuff. All right, get a bonus sky time as well later, peeps.